As I said, we will see how to control a reactor, how to measure it, and how to know if it is in good condition. With regard to reactors, you have seen in the circuit that the only thing they do or have to do is to let the electrons pass, only producing a small modification in the time in which they will travel. Therefore, a reactor has to let the electrons pass almost freely. It does not have to have resistance to the passage of the same. If it starts to have resistance, we will have problems in an inverter electronic circuit, and those are the cases in which, for example, we have overcurrent errors. So if you have overcurrent error or even low voltage, check the reactor. If you have a low voltage error, I refer to although the voltage is in good condition, we place the multimeter in resistance and the resistance has to be almost 0.6. Notice that the multimeter only has 0.3, then 0.5, 0.4, almost 0 in its resistance, so it has to be. And obviously towards its housing it has to be open, completely open. There must be no continuity. Any defect in this causes us errors in the systems, errors that the board does not know how to say. What do I mean? These are the type of errors that the board will not say reactor error. You have to understand it, because you understand the operation. And of course, any technician looks here and finds a resistance perhaps of 2 or 3 ohms and says, well, this is fine, it has continuity, but 2 ohms is too much, there has to be less. And there is the problem. If this becomes faulty, it can be due to several reasons. For example, it got wet and went into a short circuit. Or for example, another error. Here there are solders between copper and metal. This solder can be carbonized, so in this case you have to clean it well. When we talk about welding, you will learn how to do these cleanings and how to solder again and how to use this year of good quality to put these parts back together. This is in sight in this model, but in some models it is hidden and I will show it to you. In this model those connections are hidden. Here you have to disassemble that paper and solder again those unions between copper and iron. In case you have to replace it, the value that you have to see and take into account are the milliamperage and the ampere. These are the values to take into account. The milliamperage have to be as similar as possible, and the amperage has to be equal or higher. The larger the equipment, the thicker the copper filaments will be. Well, this in the case of the reactor, which is the simplest component to check, but we also have the 5th diode and we also have the transformer. So now, in the next video, we will see how to do these measurements.